everyone. First and foremost, my apologies if I can come to class today. However, I made this video discussion so that we could continue with our lesson. So this discussion will focus on the assignment that was given to you last Monday. So I'd like you to compare your answer that with the discussions we'll be having right now. And then at the end of these two items, I'll be giving one or two more items for practice, which we will be checking in the next meeting. Okay? Please feel free to pause this video if you need to and then copy down notes. Let's begin with item number one. Okay? So for item number one, this is actually quite easy. We can just directly proceed at applying the trapezoidal rule. So to make it a lot easier, we can organize this in a form of a table so that we could directly easily see the intervals. All right. So if you try to look at the first point here, it's actually okay. We have first and foremost we have x, and we also have y. So our first point is 1 for the x and then 5 for the y. Then we have 1.6 and then we have 4.32. I'm now referring to the second point. And then just follow through. We have 2.2 and then 3.87. And then we have 2.8. And then we have 3.57. And then we have 3.4. And then we have 3.37. And finally, we have 4 and 3.25. So basically, this is our table of values. So just to give a brief discussion on trapezoidal rule, the trapezoidal rule is actually a rule that we can use to approximate the area under the curve if in case the function is unknown. So instead of solving it using integral calculus, we can just break this into several trapezoids. Trapezoid is the best shape to use in order to approximate it. Okay? And of course, we can make use of this formula. So if you try to look at it, in the trapezoidal rule, we are breaking this into trapezoids of equal width, or we say this is the height. In the trapezoidal formula, this is the height of the trapezoid. Okay? And this width pertains to the differences or intervals in the x. Because this is horizontal, so intervals in the x. So we have to look at the x interval. Oh, sorry, let me just erase this. Sorry. Let's look at the x interval. This one. Okay? Okay? Okay. So if we try to inspect the x intervals, so this is 0.6, 0.6, 0.6, 0.6, and then 0.6. That means our width, the width or the height of the trapezoid is 0.6. And we need this in the formula. And basically, these are your parallel legs. So here we have formed 1, 2, 3, 4, 5, 5 trapezoids. So if you count, this is 1, 2, 3, 4, 5 trapezoids. But then we have 6 parallel legs. So to make them aligned with the number of trapezoids, the first parallel leg, we can name this as y sub 0. We write this as a subscript y sub 0. And then y sub 1, y sub 2, y sub 3, y sub 4, and then y sub 5. So this will tell us that there are really 5 trapezoids. So we begin with y sub 0. Now what's the value of y sub 0? Basically, y sub 0 is just the y coordinate, which in this case is 5 units. And so on and so forth. So everything is already provided to you. All you have to do is just to use the formula. Okay? So let's now go back. So the area of the region underneath the curve can be approximated using the trapezoidal rule, by which we say the trapezoidal rule has this formula, which is half times the constant width or height, which is 0.6, times the y sub 0, which is 5, plus the last y, which is 3.25, okay, plus 2 times all the y's in between them. So the y in between them are 4.32 plus 3.87 plus, okay, let me just erase this one. I think this is not enough. Let me just adjust. Again, we have uh, 5 plus 3.25 plus 2 times. We have 4.32 plus 3.87 plus 3.57 plus 3.37. This is simply the trapezoidal rule. And then from here, you can use your GDC. Don't do it manually. So the area underneath the curve is approximately, take note, it's an approximation. Okay, at this point, I'd like you to pause the video and then work it out using your calculators. All right. And once you do so, you would be able to get an answer which is equal to 11.6. What's the unit? The unit given here, oh, there's no unit given. As such, we can just say unit, and since it's area, squared. Okay, and that's it. Pause this video and copy down notes if you need to. Let's now proceed to item number 2. Now, item number 2 needs a lot of analysis, really a lot of analysis. So pause this video first and try to analyze once more before you try to head on this. However, if you have answered this already, then you can compare your answer that with whatever will be coming up right now. All right. So if you have read the problem, if you've analyzed it, what we're looking for actually is the volume of this water. The volume. Now, volume is a three-dimensional quantity. Okay, so we need 3 dimensions. Area is only 2 dimensional. All right. Therefore, we need a third dimension in order to find the volume. But before we reach to the volume part, you have to analyze first what you need to find here. Now, if you try to look at it, of course, you are asked to use trapezoidal rule. Now, when you apply trapezoidal rule, everyone, what you are getting, especially if you apply it to this curve, note the orange curve to this one. The curve here is this. This is the curve. So using the trapezoidal rule, what you are getting is not the water, but then it's the area underneath the curve. This one. This is what you're getting. This is using the trapezoidal rule. Now, question is that what we're looking for in the problem? No, it's not. What we're looking for in the problem is the water. What we're focusing on the problem is the water. So in this case, is there a way for us to find the water itself? Or the area of the water? Let's talk about the area first, not the volume. Yes, there is. Now, if you try to look at it, if we focus on this part of the water, okay, let me erase this one. Now, this area, this part of the water, up until the end of the curve, can actually form some sort of a rectangle. Try to see. At which this rectangle has a certain area which we can solve. So this rectangle has the following dimensions of 4 units and, oh wait, let me erase to make it clearer. 4 units here, or meters, because we're using meters. If you try to read the problem, the unit given is meters, 4 meters, and the width is actually 7 meters. So basically, the entire rectangle's area is actually equal to area of the rectangle is actually equal to 7 times 4 or 28 meters squared. Now, part of this rectangle is the water. Now, is there a way for us to find the area of the water? Yes, there is. Because all we need to do to find the area of the water, which is what we're focusing, we just have to remove the area below the curve. The area below the curve is the red one, the one that we've shaded red, from the area of the rectangle. So basically, if we try to remove this from the rectangle, we will be left with the water. Okay, this is what's left. In other words, when we say remove, the operation is subtraction. That's the reason why the trapezoidal rule is still needed, because the area below the curve, which we need to remove, can be solved using the trapezoidal rule. Okay. Now, how many trapezoids here? It says 7. So again, take note, in my previous example, we start with y sub 0. So basically, this is our y sub 0, y sub 1, y sub 2, y sub 3, y sub 4, y sub 5, y sub 6, y sub 7. All right? So there are basically 7 trapezoids here that can be formed. Now, how about for the x? The x is the width or the height of the trapezoid. If we rotate it, it's the height. But in this case, it's the width. So the width must be constant. So if you try to look at it from 0 to 1, from 1 to 2, from 2 to 3, and so on, the interval is 1. That's why our x is 1. So we can now go ahead and find the area below the curve by means of trapezoidal rule. So area below is equal to 1/2 of 1 times y sub 0, which is 4, plus y sub 7, which is 4 also, plus 2 times the y's in between them, which are 3 plus 1 plus 0.4 plus 1 plus 2 plus 3.4. Okay? Pause this video, go ahead and solve. Okay? This one, and eventually you can now play the video equal to 14.8 meter squared. So this is now the area underneath the curve. Again, we wanted to find the area of the water because in this case, what we wanted to find is the volume of the water. So we focus on the water itself. But we already know from here that the area of the water will just be the area of the rectangle, 28, minus the area below, which is 14.8. Okay? Therefore, this would give us 13.2 meter squared. So the area of this water is 13.2 meters squared. That's the area of the water. However, you wanted to find the volume, the volume of water passing through in this point. And we're given that water is flowing at 0.8 meters per second. Okay? Now, we wanted to find the volume of the water in 1 minute. Now, take note, in 1 minute, because the rate given, okay, let me just write it here. The rate given is that water is flowing at the rate of 0.8 meters per second. This is how much water is coming in. Okay? And we wanted to find the volume of the water in 1 minute. Now, we have to convert the time into the same quantity. So in this case, it's better to convert the time into seconds. That means instead of writing 1 minute, we can just write, so it's actually 1 minute, or we can just write 60 seconds. That means if there is zero point 0.8 meters per second, if the amount of water coming in is zero point 0.8 meters per second, that means in 60 seconds, there must be 60 0.8s. Remember that in 1 second is zero point 0.8 meters. In 2 seconds, that would be 2 times zero point 0.8. In 3 seconds, there must be 3 times zero point 0.8. So in 60 seconds, that must be zero point 0.8 times 60. This is how much water comes in 1 minute, which gives you 0. Which gives you zero point 0.8 times 60, which is 48 meters. This is how much water comes in 60 seconds. And this is our third dimension. Okay, remember that we're looking for volume, we're looking for the third dimension. We now have the area of the water, and this is how much water comes in. So we can now find the volume of the water in 1 minute, by which the volume of the water will just be 13.2, the area, it's meter squared, times the other dimension, 48 meters, thus giving us, pause this video and work it out in your calculator. It gives us three significant figures, 3, 4 meter cube. So this is the volume of water coming in the river in 1 minute. All right? And that's the end of your assignment. So I'd like you to copy down notes if it's necessary, and then please proceed at the activity that I'll be providing. Thank you so much, everyone.